Good. 12,039 characters within range, and the only uppercase clusters remaining are pronounceable brand names Musa, CUDA, and GL from OpenGL, which are allowed per the brand name exception. Here is the final script. On the bench in front of us sits a boxed desktop graphics card, sold under the More Threads name, the exact kind of object a gamer in Chengdu or Shenzhen could carry home this week and slot into an ordinary tower case. We are going to take it apart the way an anatomist works through a specimen, moving from the outer shell down toward the die itself, and the deepest layer does not match the story printed on the box. This is not a prototype kept behind glass in a government lab. It is a retail product with a barcode and a warranty card, built to be judged the same way any consumer graphics chip is judged against the very company it was designed to challenge. The path runs from the compute cores buried under the heatsink, through the memory chips beside them, out to the display ports on the back panel, up into the driver software that has to make all of it behave, and down into the question of who actually owns the tools that printed this die in the first place. Each cut answers a narrower question than the one before it, and the narrowing is the point. Outer shell first, then cores, then memory, then output and software, then the foreign equipment underneath all of it. The unit on this bench belongs to the company's S80 generation, the most widely available consumer card the company currently sells through ordinary retail channels rather than through a government procurement list. Pull the cooler off and the card looks unremarkable, which is itself a fact worth stating plainly. It uses a standard ad and card shape, a blower or open air cooler depending on the model, and it plugs into the same expansion slot used by any desktop graphics card sold anywhere in the world. That ordinariness is the company's own claim, taken from its retail listing rather than from an independent lab measurement, and it matters because it tells you the object was built to be installed and used, not displayed as a symbol. Underneath the cooler sits the die itself, built on the company's own architecture, called Musa, rather than on a licensed block borrowed from an existing graphics maker. The shading and compute cores on this die are a genuine design, not a relabeled copy. And that distinction matters because plenty of attempts in this category have turned out to be the latter. The company states its own core counts and clock figures, and no independent die shot with verified transistor counts has been published to confirm them, so those numbers should be read as a claim rather than as measured fact. The die is fabricated on a mainstream foundry node, not on the most advanced node available to the incumbent it is competing against. That gap is not a marketing choice. Advanced lithography access for Chinese contract foundries is restricted under the same export framework this card exists to answer, so the die sits on the node it was permitted to reach rather than the node its designers would have preferred. The cores underneath this shroud are, in a real sense, a record of a negotiation between ambition and permission. One layer below the cores sits something easy to overlook, which is the translation layer that turns ordinary game code into instructions this particular architecture can execute. Because the instruction set is new rather than inherited, the company has had to build its own support for the graphics standards the existing library of desktop computer games actually calls, including DirectX, Vulkan, and OpenGL, and it describes that support as a continuing rollout rather than a finished feature. Independent reviewers report that coverage and frame behavior vary noticeably from one game title to the next, which is a second and separate symptom of the same root condition. Beside the cores sit the memory chips, and this is the layer where the global supply chain shows up almost untouched. The card uses graphics memory bought through ordinary commercial channels at a capacity and bus width the company has published in its own spec sheet, putting it in line with mid-range cards from established makers rather than at the high bandwidth tier reserved for flagship parts. These memory chips are commodity components available to any buyer on the open market, and nothing about them needed to be built domestically, which sharpens the contrast with the layers around them that clearly did. Follow one of those memory chips back through the chain for a moment. It was designed and fabricated by an established foreign memory supplier, shipped as a finished part, and soldered onto this board exactly as it would be soldered onto a card from any other manufacturer. The card around it is Chinese in blueprint. The chip feeding it data is not, and nobody involved is hiding that fact, because memory sourcing was never the part of this story under restriction. The back panel carries a conventional set of display outputs supporting current resolutions and refresh rates, matching the company's published specifications, and the card's hardware encode and decode blocks are advertised to handle the mainstream video codecs buyers expect. Independent verification of real-world encode quality against established competitors is thin, with most public comparison coming from enthusiast channels running their own test clips rather than a standardized lab with disclosed methodology. This layer is also the one least touched by restriction, since display controller designs and codec licensing are broadly available, so its competence says little about the limitation this dissection is actually tracking. The driver and software stack is where the verdict on this card is genuinely being written, more than at the die. More Threads has released and continued updating drivers for both major desktop operating systems, along with a software toolkit meant to ease porting work away from the dominant graphics ecosystem built around CUDA. Independent testers and forum reports describe compatibility gaps, crashes confined to specific titles, and frame pacing that is inconsistent in ways the company's own release notes do not mention. And the company's own continuing updates are themselves an admission that this layer remains unfinished. This is the layer where years matter more than die area. The dominant graphics maker carries more than a decade of per-game optimization work, profiles tuned title by title, and a software relationship with developers that cannot be taped out in a single product cycle, no matter how competent the silicon underneath turns out to be. The bottleneck exposed here is not the chip. It is the accumulated software behind the chip which a new entrant inherits none of and must rebuild one title at a time. Read against that backdrop, domestic production looks less like an attempt to win this generation of consumer benchmarks and more like a hedge against a future disruption to the supply of foreign-made cards altogether. A company building toward worst-case shortage designs differently than a company building to top a benchmark chart this quarter, and the choice is visible so far: a mainstream node instead of the newest one, a driver stack still being filled in title by title, a willingness to ship something imperfect through ordinary retail rather than wait for it to be finished, all point toward the first kind of company rather than the second. The deepest layer sits below all of that, in the equipment that actually printed this die. The architecture is designed in-house, and assembly and testing happen domestically. But the wafer itself is etched using lithography tools and electronic design automation software that trace back to non-Chinese suppliers, the same equipment categories named directly in the export framework this card was built to answer. That dependency is documented in broader industry reporting on China's semiconductor supply chain, not in any disclosure from More Threads itself, and it extends down to the specific etch and lithography tools used by the contract foundry that physically printed this part, tools the foundry itself does not manufacture and cannot yet replace with a domestic equivalent at the precision this die requires. That is the fact every shallower layer was pointing toward without saying it outright. The restriction aimed at denying advanced graphics silicon to Chinese buyers has not produced a chip that is immune to that restriction. It has produced a chip that is an honest record of exactly how far a design team can get, while still depending, at the fabrication and tooling level, on the same global machinery the restriction was meant to wall off. The die on this bench is not proof of independence. It is a measurement of how much independence is currently achievable, and that measurement is partial, visible in the node it was printed on, the game compatibility it is still filling in piece by piece, and the foreign equipment list standing behind the foundry that made it. The restriction's original intent was a clean line between access and denial. What this die shows instead is a gradient, a design fully owned sitting on top of a fabrication process that is not, and the distance between those two states is the actual policy outcome, not the binary the original framework assumed it was creating. There is one way to hold that gap in your hand rather than as a percentage. Owning the blueprint for a house is not the same as owning the quarry, the kiln, and the cement plant. The blueprint depends on, and More Threads has clearly drawn its own blueprint while still firing its bricks in a kiln that in large part belongs to someone else. Three things this dissection cannot settle deserve to be said as plainly as everything before them. Whether this card is a real commercial threat to established consumer graphics sales or a subsidized hedge against future supply shocks cannot be answered from the bench because no audited sales figures exist, only the company's own statements and coverage in Chinese trade press. No independent, standardized benchmark suite comparing this card directly against current cards from established makers under identical conditions has been published by a recognized testing outlet, so any ranking beyond the company's own slide stays provisional. And the physical limits of the node it is built on, including power efficiency and thermal behavior at higher clocks, along with the yield and long-term reliability of domestic fabrication runs at real volume, remain unverified by anyone outside the company and its manufacturing partners. Put together, what this specimen does not show is nearly as informative as what it does. A working chip with an unresolved software story and an unmeasured place in the actual market, sitting on top of a manufacturing base that is still partially borrowed, is not a contradiction. It is the honest shape of where this technology currently stands, somewhere between a finished competitor and a closed laboratory exercise, closer to the former than skeptics assumed and farther from it than the company's own marketing suggests. What this card actually proves, cut by cut, is that a Chinese design team can now produce a desktop graphics chip competent enough to ship, sell, and be installed in an ordinary computer. What the same card cannot yet do is manufacture its own way out of the dependency that export restrictions were built around, and those two facts are not opposing conclusions. They are the same die, examined from two directions on the same bench, under the same light, and only one of those two directions is currently within this company's own control. Owning the blueprint turned out to be the easier half of the problem. If you had to choose the next object for this table, which would you put under the light? The foundry tool that still cannot be replicated at home, or the next chip that tries to get around it anyway? If that question interests you, subscribe and turn on notifications so you are there for the next time we open something up.